Okay, this is almost the end of this whole thing. This corollary says if n is just arbitrary composite number, then it can be written by this product of powers of primes by the unique prime factorization theorem, right? Then the phi of n simply n times 1 minus 1 over p1 times 1 minus 1 over p2 up to 1 minus 1 over p sub k. It looks complicated, but proof is simple and it's very understandable why we get this form. First of all, in the previous theorem, we proved that phi is multiplicative. We didn't use this terminology in our course, but in number theory, it's very useful fact for any function, which means if any number is multiplied by two integers which are relative prime, then it can be separate. That's the statement of previous theorem. So just to compare this number p1 to the a1 and the remaining part of it, then that two numbers are relative prime because p1 to the a1 is just powers of p1 and the remaining parts is powers of p2, p3 or pk, and p1 through pk's are primes because it's prime factorization form, right? So there shouldn't be any same primes right in there, which means any powers of two different prime numbers are relative prime, right? So if we use the previous theorem, we can separate this phi of n into phi of p1 to the a1 times phi of the remaining parts of it. But we can apply same rule for the remaining part of it, so that is also can be separate to phi of p2 to the a2 and phi of the remaining one. So if we just keep doing it, eventually we are going to get phi of n is equal to phi of p1 to the a1 times phi of p2 to the a2 so far up to phi of pk to the ak. Then in theorem 57, for each of these is going to be phi 1 to the a1 minus p1 to the a1 minus 1 because it's powers of prime. Then for any j could be 1 through k, but for any j, that one can be written by this way. Like if you factor out pj to the aj, of course the aj minus 1 is a smaller power, but let's pretend we factor out this bigger power term. Then the first one changed to 1, that's the remaining part, and second one we actually factor out one more pj here, right? So we have to have 1 over pj, right? So if you multiply this 1 over pj times pj to the aj, then it should be same as pj to the aj minus 1. So that's how we got this form. And the only reason why you want to do that is this phi of n is product of these numbers, and each one of them looks like that. So it's a product of that number from this and that from here and up to this much, right? Then we can collect this p1 to the a1 times p2 to the a2 up to pk to the ak in front of it, and put all this 1 minus 1 over p1, 1 minus 1 over p2 later, like that. Then this is actually the integer n, right? Because n is like this, right? So this is typo, it should be n, right? So p1 to the a1, p2 to the a2 up to pk to the ak is simply n, and n times the remaining parts of it. That's how we got this formula.